Welcome back to the series, episode 11, where we're going to go mainly into adding a string data type as well as a printf function to use these strings and actually be able to see. So this printf function will be very similar to the C implementation. So we can use %i in order to and extra parameters into the printf function to put the result into our string. So this is just %i, so we'll add an integer here. So we'll call our add function that we've declared up here to add 2 and 3. So when all this is said and done, our console should say apples 5 here. So now we got all this code ready, and this is our goal for this episode. We're going to start off with our token.py. In token.py, we need to add a new token type for our string. So string equals string in our token type enum. And then we'll need to scroll down to our type keywords, and we're going to add 2 new keywords, one for string and one for void. This is just something I forgot to do. In our Lexer, we're going to do, let's go underneath the comma. So we'll add a new case for our double quote character. And this will be the same thing as everything else, except we'll change this token type to string. And in order to read this string, we're going to need a new helper function to help us do that. So we're going to change this to __ read string. And we're going to make this, we're going to keep track of a position variable, which will be an integer, self.position +1. Do a while true loop. Every time this loop does an iteration, we're going to read a character from our source string. If the current character is equal to another double quotes, or the current character is none, we're just going to break out of this loop and say we're done. This string's obviously ended, or there's some type of, or the file is ended, so there's some type of an error. So after we're out of this while loop, in our AST we're going to add a new literal to our node type enum. It's at the very bottom. And then we will go all the way down to, and we'll add in our string literal node. I'm just going to paste it in for the sake of time, because it's very similar, if not exactly the same, to all of our other literals, except this value is just a string data type. So we'll just implement the init function, our type. In our parser, we can import the new node that we just created. We can go down to our prefix parse functions in our init method of the parser. This function will be a token type .string, and its function will become a self._. We'll add a comma just for later. Now the only thing we need to do in this parser is implement our parse string literal function. So we'll scroll all the way down to our other parse literal functions. Do def parse string literal self. We'll return a string literal node. And all we're going to do in this function is create a new string literal class. Value equals self.currentToken.literal. That's everything we need to do for the parser now. So moving on into the compiler. We're going to start it off by importing our new string literal node. We're going to go to our type map, and since we added new types to our token file, we need to add them here for how the compiler is going to see those types. So we're going to add string, and that's going to be an ir.pointer type. And that type of pointer is going to be an int 8. So an i8, or the same type as a character. Below that, we'll add void, the ir.void type. And that's also, like I mentioned before, going to be used later down the line. We're going to start off with our print function to kind of get that out of the way and get off the strings for right now. So in our initialized built-ins, we're just going to add a new function here called initPrint, and that's going to return an IR function. We're going to get our function type set up. So fnty function type is of type function type equals ir.function type, and we're going to start with the return type of this function. So it's going to be a self.typemap. We use our integer type. The arguments of this function is going to be a string, so ir.intType 8. So an i8, and we're just going to pass it in as a pointer to those. And then var_arg is going to be equal to true, because this could have multiple parameters, so we want to make sure we handle them all. Now all this function is going to do is return an ir.function object. We pass in our module, self.module. We're passing our function type. And then we're going to pass in the name of this function. We want the compiler to register as, so printf for now. Now below all of this, we're going to enter down, get some space. We're going to set our environment now. We need to give let our environment know we do have a printf defined. So self.env.define. We're going to call the init print function for that function type that we created in this function object. And then we're going to set the type of this function, or pretty much the return type, to an ir.int type. And it's just going to return a 32-bit integer. And that should be everything we need to do for printf. This absolutely needs to be named printf right here. When you get to the environment part, this could be named yeet for all LLVM cares. This is on our side. So whatever we want to define this function as is yeet. But this printf needs to be set in the LLVM function object, because this will point directly to the C implementation of printf. But just for now, I'm going to keep them both the same. The next thing we're going to do is complete our strings. So we're going to go down to our resolve value function. So I'm just going to search for that, click on one of those to take me straight here. Now in the case statement underneath Boolean literal, I'm going to add a new case, node type dot string literal. We're just going to set node equal to string as a string literal type just for the IntelliSense part. We're going to name string type. We're going to take out a tuple from the self dot underscore underscore convert string method. And we're going to pass in the node.value, or the Python string it's referring to. And then we're just going to return back the string and the type. Now we'll implement the convert string function, so we'll do that underneath resolve value. So def convert string, self, string is of course going to be a string, and this is going to return back a tuple where the first value is a constant, and the second value will be an array type. Now this may look a little confusing, but it's just initializing the string in LLVM so it knows the location and what to refer it to. So the first thing we're going to do is we're going to do string equals string dot replace, and we're going to place all of the \n's in the new lines with a \n \0. So just like adding a null terminator. I'm going to create a format variable equal to the string, and we're going to add that null terminator to the very end of our Python string as well. We'll have our C format, which is going to be the constant version. It's going to be ir.constant. The type is going to be an ir.array type. The element types in the array are going to be int8s, so int type 8. And it's going to have a length or a count of the length of the format string up here, so how many characters are in that. And then outside of this array type parentheses, we're going to add a comma, and we're going to set the constant value as a byte array, and we're going to encode, fmt.encode, the format string as UTF-8. So we're going to make sure it's encoded that way. Now we need to create the global variable for LLVM for this string. So we'll set a variable global fmt equals ir.global variable. I'm going to pass in our module. Our type is next, so cfmt.type. And then we're going to set our name here just to keep everything from, or keep things from, if the strings are the same value, or we don't want to have the same names for every global variable because they need to be unique. So we're going to add a underscore string underscore, and then we'll add a call to our increment counter to grab just a new integer. We're going to set this global FMT's linkage to be internal. We'll set the global FMT's global constant equal to true. And then we'll set the global FMT's initializer to be our CFMT. So we're going to initialize this global variable with this constant value. And finally at the end we'll return our global FMT, which is just our global variable reference, and then our global FMT, the type that it is. So it will just be a CFMT type, so this constant type which is an array of characters, so I8s, and the length of that string that we had up here. And we'll save that file. And strings should be perfectly implemented now at a very basic level. So we'll do our very last thing is to get our print function fully working. So we'll add a new function underneath the convert string. We're going to set it to the name built-in printf. Take in self. We'll have a parameter. That's going to be a list of ir.instructions. And then return type is an ir.type. Now I could go on for hours explaining how this code works. However, this is basically mapping the C printf function. So I'm just going to paste it in here. There are some limitations with the LLVM Lite library that cause this. So in my C# series, this is handled way more elegantly and able to be understood a lot easier. So all we're going to do is we're going to look up our printf function from our environment. We're going to grab that function object and its type, but we're not really going to use its type. We're going to allocate a string with our return type here. We're going to store that string in the compiler, and that the first one's going to be our param0, so our first parameter in our print function. So right here, we're going to store that store that in memory. We have the rest of the params here, which is just everything beyond. If the first one is actually a load instruction, so if we are using a variable we're passing in a variable into this print function, we need to handle the load instruction slightly differently than just a straight up string. So we'll get that load instruction. We're going to get the global variable pointer from that C format instruction. We're going to load the string's value from that global variable. We're going to bit cast it to just make sure it is a pointer to I8s, so a string or characters. And then we're going to return a call instruction to call that function with those arguments. If we're just using a normal string like we're going to be doing in our example, we just need to bit cast the global. So we're going to get that global and we're going to get the counter to that as well. And we're going to make sure that type is a I8 pointer. And then we're going to call that function the same way. Now this only works with printing integers. I've had a lot of headaches trying to implement floats, but the C# implementation is way better than LLVM Lite, so that will make a whole lot more sense. But if you do have a solution that's pretty readable, make sure to join the Discord and ping me on that, because I can update these videos. We'll do our final thing, which is a visit our call expression. So I'll go to our expressions region. Let's go down until we see visit call expression. We'll come down to this match statement. Now that we do have a name, instead of just defaulting to the default case, we can add our printf name. We'll set the return value to self.builtinprintf. We'll set params to our args, and then return type, if I can type, will be types at the first index. And our return type, we'll make that equal to our type map integer. And that should be everything we need to run this. So we'll go to our test.lime file. We'll come down to our terminal where our Python environment is activated, and we'll type in python main.py. And now we can see apples 5. So we can change this to like 12, and that should say 15, apples 15. So that'll conclude our adding our strings and our printf function to our language. Very basic implementation. There's a little more you could do, but the LLVM Lite library is just feels very limited and very complicated to get working compared to C#. So this is where we'll end off here. Make sure you join the Discord if you have any questions or run into any problems. And on our Discord, I have the link to the full series code on our GitHub. So if you want to skip ahead and look at some of the code for the later episodes, you can there, and a little sneak peek of our next series. So thank you for watching, and I will see you in episode 12.